And welcome back to the Turdford Show. All right, today's video is a user requested video, and you can probably tell from this picture that it is a projectile. And let's go ahead and take a look at it. It says that a golfer hits a ball at an angle of 25 degrees, so that's important, to the horizontal. If the ball travels at a horizontal distance of 301.5 meters, what is the ball's maximum height or maximum vertical displacement? So there's all that the question is asking. Now, right off the bat, let's go ahead and do something. Let's go ahead and add some little details here. So we know that this angle is 25 degrees. All right, that's good to know. We also know that this horizontal displacement is 301.5 meters, and that's also very good information to know. Now, I'm going to go ahead and tell you something. You can go ahead and crack your knuckles. This is a harder problem. And so now you may be going, well, how do I know this is a harder problem? I can go ahead and tell you, and this is from doing this for a gazillion years, if a problem gives you VO, if a problem gives you theta, if it gives you those two things, it's going to be an easy problem, at least in terms of physics goes, because that is not going to be a hard question. I know this problem is hard right off the bat for one reason. It did not give me the velocity initial of this projectile. So you can go ahead and crack your knuckles and get ready to work this problem. So let's go ahead and take a look at something. We've got, here's our projectile, and going up, 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 and down, down, back, down, down, down. And what this problem's actually wanting us to find is this maximum vertical displacement, this Y. That's what the problem's looking for. And if you've watched any of my other videos, you've heard me say umpteen times, it's a little catchphrase from coaching physics teams. If I say how high, I want you to say third equation. And you may be going, well, what is the third equation? Well, you've seen me write before. And from now on, if I say how high, I want you to say third equation. So third equation is this. You've wrote it before. Vy squared equals Voy squared plus 2ay. There's my third equation. Now, why is that third equation such a handy one for what we're looking at? Simple. Why that equation's so handy, look at where we're looking at. We are looking at the top of this projectile's path. And what's cool is at the top of the projectile's path, its velocity in the y direction is 0. And that's what simplifies this problem. But now, here's the catch. We're looking for y, and we don't know VOY. So we've still got some issues here. But obviously, we're going to use this equation. So now your goal to me should be to say, well, how do we find VOY? That's what we need to focus on. Well, let's look at something. It gave us x, so let's see what we can't do with that x. Well, usually I would say, what's the only equation good for x in a projectile? I've said that a million times in my life. What's the only equation good for x in a projectile? And usually what most people say is x equals VOXT. And for the most part, they're right. There's just one thing. This equation's not going to help us. We know x, but we don't know time, so therefore we can't find VOX, so that's not going to help. But what's cool is there is one other equation for x, and it's known as the range equation. In one of my other videos, I derived the range equation. The range equation looks like this. X equals, oh, that's a horrible equal sign, isn't it? X equals VO squared sine 2 theta over g. Now, the reason why you don't hear me using the range equation a lot, the range equation only works for a perfect projectile like this one. You may be going, Turdford, what's a perfect projectile? A perfect projectile is when your y initial is 0 and your y final is 0. That's what lets you derive that equation. If you want to know how to derive it, go look for my video on the range equation and you can learn how to derive that. It's a fun video. I love deriving equations. You may not. Let's go ahead and do something. Look at what you know in this problem. You know that x is 301.5. VO square of sine of, and I find a lot of people don't know how to do the 2 theta, but literally it just means 2 times whatever your angle is. So you're going to take the sine of that over G, which is 9.8. Well, let's go ahead and do something. Let's solve this for VO. So let's multiply both sides by 9.8. And so let's see what we can get here. And I'm sorry I don't have a calculator on my screen. It's actually, I'm on a Surface Pro right now, and I don't have any software really installed on it. So this is 2954. Let's just go 2955 equals VO square. And let's just go ahead and rewrite it like this. Times the sine of 50. And now let's divide both sides by the sine of 50. And that's what you should be doing right now as well. It's dividing both sides by the sine of 50. So 2955 divided by sine of 50 is, look at this, it's huge. He hit that golf ball 3,857 meters per second. That would be incorrect. He did not hit the golf ball that fast. You got to remember, you still got to take a square root of both of these sides. So let's take the square root of that answer. And we've got 62.1 meters per second. And so there, see if I can make a little better 6. So there is my VO. Now, why am I so happy? Well, I have a VO now. And what's awesome is this. If I have a VO, so I now know on this projectile that VO is 62.1 meters per second. That means I can find VOX if I wanted it. VOX is VO cosine theta. And we know that theta is 25 degrees. And again, I don't even want that. What I really want in this problem, I want that. I want to know what this VOY is. VOY is VO sine of theta. And so now let's go and find that. VOY is equal to VO. And you're saying, why are you writing the equation again? Because I want you to memorize it. So 62.1 times the sine of my 25-degree angle. So I'm going to punch that in my calculator. Here, race me. Punch it in yours. Are you doing it? Are you beating me? You haven't beat me, have you? So that's equal to 26.2 meters per second. So there is my VOY value. And now what's cool? Pop quiz. See how you do. If I say how high, you say da-da-da-da-da-da-da. Third equation. And so now let's write down that third equation. VY equals VOY, forgot my squares, plus 2AY. And look at what we know. VY, the velocity in the y direction at the top of that circle is 0. VOY is actually 26.2 square. 2 times negative 9.8 is negative 19.6y. And now let's solve that equation for y. 26.2 squared divided by 19.6. Ladies and gentlemen, 35 meters is the maximum height of that golf ball. Anyway, I hope this helped. It's been a pleasure. It actually took me 3 times to make this video because this Surface Pro 3 keeps messing up. Excuse me, this is a Surface Pro 4, but anyway, rather a pain. But anyway, this is the correct answer, and I hope this helps. Anyway, later.